Power of accommodation. So what does it mean? See, the thing is, our eye is able to see something as close as 25 centimeter and as far as infinity. So it's able to see such range of objects. So, but the eye size will remain the same. In whatever the case is, the size of the eye will not change. Apparently it's around 25 millimeter, if not 2.5 centimeter. If you guys are curious, you can take up a scale and look at 2.5 centimeter, how big that is. Okay, this is the size of the eye, that is fixed. And the distance from the lens to the retina is also fixed. So my question to you guys is, where is the screen? If I consider this entire thing as your, say, normal lens and object and screen and all of that. So this is clearly the object and this is clearly the lens. Where is the screen? That's my question. This is your screen, is it not? So the distance of the screen is fixed though, you know. So from the lens to the screen, that is fixed. That is, V is fixed. Image distance is fixed. So in whatever the case may be, here the object is at infinity, but this will not change, and the distance from the lens to the retina is fixed. V is fixed in both the cases. And say we'll take it approximately being equal to 2.5 centimeter for the ease of calculation. Of course, it's not true. It will be lesser than that, but for the ease of calculation, I'll take it as 2.5. We can take it as 2 actually. Okay. A bit lesser. I'll take it as 2. So we are able to see an object which is as close as 2.25 centimeter and as far as say infinity, but I've taken a value of 1 kilometer. In centimeter, it's around 1 lakh centimeter. So my question to you guys is, what should be the focal length of this lens so that we get an image over here? So this particular object image, I mean whatever light is coming from there, should be an inverted real image over there. Inverted real image over here also. So how does that happen? What should be the focal length of this? So 1 by f is equal to 1 by v minus 1 by u is your formula. So 1 by f is equal to 1 by, the image distance is fixed to be 2 centimeter and the object distance is 25. LCM is 50. So 25 minus 2, that is 23 by 25. So f is equal to how much, guys? F is approximately 25 by 23, so many centimeter. 25 divided by 23, 1.086. Wait, I think, no, sorry, this is 50, my bad. The LCM is 50, right? 50 divided by, right, 50 divided by 23, 2.17 centimeter. Okay, the next case, here 1 by f is equal to 1 by 2. The image distance is fixed while the object is at 1 lakh centimeter away. So LCM is 1 lakh. So this will be around 99,998 divided by 1 lakh. This is 1 by f, by the way, right? So f will be equal to the inverse of that. So 1, 2, 3, 4, 5 divided by, oh no, this is not that, my bad. I'm doing the math wrong altogether. This is the 49,999. So 1 lakh into 1 more 0, right? Divided by 49,999. 2, almost equal to 2 centimeter. So point I'm trying to make is, from this extreme to that extreme, the focal length has to change. Anything in the middle, okay, sorry, this is the 1 kilometer. For infinity, this again will be approximately equal to 2. You can take up different values, take up 10 kilometers, if not distance of the moon. So take that and check out what should be the focal length, so that, see, we see the moon, is it not? So our focal length has to be that at that moment of time, right? So what I'm trying to make, the point which I'm trying to make here is the focal length is changing. So in this case, the focal length was 2.17 centimeter, and in this case it is 2 centimeter. It might not see like a huge difference, but the point here is it is changing, it's not fixed. So how is this possible? We have seen glasses, right? They don't change. The lens, they don't change, but here it's able to change. That's the beauty of nature, is it not? So how is it able to change? With the help of ciliary muscle, right? So ciliary muscle happens to be a muscle which kind of controls the focal length of the lens. Not kind of, it controls the focal length of the lens. How does it do that? It's by pulling and pushing and all of that. So we're not going to the detail of it, and I don't know much about it, to be frank. So this is your point, that our lens changes the focal length to be able to see such huge difference in where the objects are, starting from 25 centimeter to infinity. Light from faraway stars are quite far, and we are able to see that. How is that possible? Because of the flexibility in our eye lens, to be frank. So the power of accommodation is nothing but that itself. Distance between the eye lens and the retina is fixed. Around 2.5 is something which I have written. I'll keep it as 2 to 2.5. I don't know the exact value, but the size of the eyes, according to few of the places which I read, it is around 2.5 centimeter. We need sharp image on the retina to see anything clearly. That's true. Without sharp image, it will be blurry. Thus, to see the objects at different position, the eye lens changes its focal length with the help of ciliary muscle. Right? We saw that our focal length has to change. Even though it's small change, but it has to change. So power of accommodation. Accommodation means what? To take everything into account. So this power of being able to take all the objects at different range and to see them. This is your power of accommodation. The ability of the eye lens to adjust its focal length of its lens in such a way that the sharp image of an object at different distance from the eye, if formed on the retina, is called as accommodation. Okay, that's actually a long sentence. I could have broken it. The ability of the eye lens to adjust its focal length of its lens in such a way that the sharp image of an object at different distance from the eye, not if formed, is formed on the retina, is called as accommodation. Okay. Now there are a few more points that we need to keep in mind. Something called as near point of an eye and far point of an eye, and the range of vision. All this is part of your understanding and your exams as well. So near point is the minimum distance at which the object can be seen most distinctly, most clearly, basically, without strain, without feeling a pain in our eye, is called the least distance of the distant vision. It's about 25 centimeter, and this is called as near point of the eye. Wherein the far point is the farthest that we can see. The farthest point up to which the eye can see objects clearly is called the far point of the eye, and it is infinity for a normal eye. Okay, for a normal eye, it can see that. So people with glasses, our far point is reduced, including me. Range of vision is nothing but from where to where a normal eye can see. It's from 25 to centimeter. Okay, that we can't miss out. Unit is important. Infinity, there's no unit because infinity is infinity, right? Okay, so this is all your write-up, and I hope I made it interesting with some numericals. Okay, so you guys can pause and copy it off.